Hi everyone. In this video I want to discuss about the irrational numbers. Irrational numbers are the numbers which are not rationals. That means the numbers which cannot be written in the form of p by q are irrational numbers. Irrational numbers includes sets, non-terminating, non-repeating decimals, etc. So in the irrational numbers, suppose we know that root 2, root 3, root 5, root 7, etc. Those are irrational numbers. Like that only, root 2 plus 3 or 5 minus root 7, etc. are irrational numbers. Or else, one more group is there, root 2 plus root 3, 2 root 5 minus root 7, root 3. Like this. These are also irrational numbers. That means I categorized irrational numbers in our concept into three groups. So first group contains only purely irrational numbers, purely one irrational number, and second group contains a rational and irrational, combination of irrational and irrational. So rational is 5 here and irrational is root 7. So 5 minus root 7 totally is an irrational number. And here if you see this type of examples, root 2 plus root 3, both terms are irrational numbers. 2 root 5 minus root 3, both terms are irrational numbers. So in this video we'll discuss about how can you prove all these models as irrational numbers. How can you prove the numbers as irrational numbers? Actually, the proof of any number, any things, any statement is of two types. Proof of any statement is of two types. Either direct proof. Proofs are two types: direct or indirect. Indirect. Indirect method of proof will take the given statement and we will write the law reasons for each and every statement and we will get a conclusion. We'll get a conclusion. But whereas in indirect method of proof, we will assuming the contradiction to the given statement. Whatever the statement we have to prove, we have to assume the contradiction to the given statement so that automatically we will get a false statement for the generalized truth. False statement for the generalized truth. So, by concluding that, we will say that it is a wrong statement what we assumed. What we assumed is a wrong statement, we will conclude. So, all irrational numbers we can prove by indirect method of proof. So, first of all, I'll explain that. I'll explain one of the model as 2 plus root 3. Show that it is an irrational number. Show that 2 plus root 3 is an irrational number. So already I said that we will prove by indirect method of proof. So what you have to prove? This as an irrational number. And this belongs to q dash. 2 plus root 3 belongs to q dash. So but we will let us assume that in the proof what we will assume? Let us assume that 2 plus root 3 is a rational number. Two plus root 3 is a rational number. We know that all rational numbers are in the form of p by q. So 2 plus root 3 can be written in the form of p by q, where the conditions are compulsory. Q is not equal to 0. P comma q belongs to the set of integers and p and q are co-primes. So first we have to prove that 2 plus root 3 is an irrational number. In the proof, we are assuming the contradiction to the given statement. That means 2 plus root 3 is a rational number. So 2 plus root 3 can be written in the form of p by q, where q is not equal to 0 and p comma q belongs to z and p and q are co-primes. So I'm taking this condition. I will prove that rationals and irrationals are equal in such a way that we will get a contradiction to our assumption, and we can prove that our statement is false. Whatever we are thinking is false and whatever is given is correct. How can I tell? Because 2 is a rational number and root 3 is an irrational number and p by q is also rational number. I'll separate rationals to one side and irrational another side. So p by q minus 2, I'm transposing 2 to the RHS. So root 3 is equal to p by q minus 2. P by Q is a rational and 2 is a rational, and on simplification it becomes P by Q minus 2 by 1 is nothing but Q is the LCM. P minus 2Q, it becomes P minus 2Q by Q. So everything becomes what? Rational in the RHS. So root 3 is irrational, we know that. Root 3 belongs to irrational numbers. And P minus 2Q by Q belongs to rational numbers. But by our statement it is saying that both are equal. Both are equal. Equal is a false statement. Is false. So rationals and irrationals never be equal. Those are disjoint sets. They never be equal. But we got here both are equal. That means what? Our assumption is wrong. What is our assumption? 2 plus root 3 is a rational number is a false. So what we can conclude? So 2 plus root 3 is a rational number. 2 plus root 3 is an irrational number. Is an irrational number. Understand here? So what we derived in the indirect method of proof, we are assumed as this is a rational number, and we got the false statement for the generalized truth that both are irrational and rational numbers are not equal. So we got this wrong assumption, and hence this is false. This is one type of model, one model in the irrational numbers. And one more example I will give. Suppose 7 minus root 5. Show that 7 minus root 5 is an irrational number. Irrational number. Follow the techniques and shortcuts what I am explaining. I am not saying always. Okay. The concept you follow clearly. So 7 minus root 5 is an irrational number. So in the same way, what you have to assume? 7 minus root 5 is not a rational number. It is a rational number. If it is a rational number, we can write it in the form of P by Q. And the conditions you have to write compulsory. Q is not equal to 0, P comma Q belongs to integers, and P and Q are co-primes. In this case, root 5, what you have to do generally 7 you will transpose to P by Q. Instead of transposing 7 to the RHS, I am transposing P by Q to the LHS and minus root 5 to the RHS so that it becomes positive. Root 5 becomes, without leaving the negativeness on the left hand side, we are transposing in such a way that, so 7 minus P by Q is equal to root 5 you will get. And again on simplification you will get 7Q minus P by Q is equal to root 5. And again we got that LHS is a rational number and RHS is irrational number, and rationals and irrationals never be equal. So our assumption is wrong, and we can say that 7 minus root 5 is an irrational number. 7 minus root 5 is an irrational number. And the second case is, if both are irrational numbers, then how can you solve? If both are irrational numbers, suppose I will take that, show that 2 root 3 minus root 5 is an irrational number. Irrational number. 2 root 3 minus root 5 is an irrational number. So here also indirect method of proof. So we have to assume that 2 root 3 minus root 5 is a rational number. If it is a rational number, it can be written as P by Q form. So I can write 2 root 3 minus root 5 is equal to P by Q or A by B, whatever you want, your wish. You can write A by B also. And the denominator should not be equal, and P comma Q belongs to integers, and P and Q are co-primes. Q are co-primes. So here both the terms contains irrational numbers and this side is rational number. I want to make it as one of the term as rational, and I will make this binomial mixed third as a single third. I want to make this mixed third as a single third. That's why I'm doing squaring on both sides. On squaring on both sides, it becomes what? 2 root 3 minus root 5 whole square is equal to P by Q whole square. P by Q whole square. And next, on LHS, A minus B whole square is there. So we have to write A square plus 2 minus 2AB plus B square. A square is 2 root 3 whole square minus B square minus 2AB, sorry, 2 into 2 root 3 into root 5 minus 2AB plus B square is minus root 5 whole square is equal to P square by Q square. You will get 2 root 3 whole square minus 2 into 2 root 3 into root 5 plus root 5 whole square is equal to P square by Q square. And here AB whole power M, first I am simplifying the LHS. In that 2 root 3 whole square is in the form of AB whole power M. The power belongs to two terms of the bracket. So 2 square 4 and root 3. So 4 into root 3 whole square becomes 3. 4 3 is at 12 minus, here you will have to multiply rationals with rationals and irrational with irrationals. So rationals 2 2s are 4 and irrationals as root 3 into root 5 is root 15 plus root 5 whole square is 5 is equal to P square by Q square. P square by Q square. Okay, then 4 3s are 12 plus 5 is 17. 17 minus 4 root 15 is equal to P square by Q square. Here what happened? I said already these two terms are irrational numbers. I made it as a single set. And now what I have to do? 17 minus P square by Q square is equal to 4 root 15. So I made it as a single set on the RHS. A single set on the RHS. So this becomes what? If on simplification the LHS 17Q square minus P square by Q square is equal to 4 root 15. So previously I explained already one rational and one irrational number third. How you proved 2 plus root 3 I explained. In that case what you did 2 we transpose it to that side and root 3 is equal to one side rational part and another side irrational part we got. If two irrational numbers are given also, we did the squaring on both sides and we simplified and we arrived again LHS as a rational number and RHS as a irrational number. LHS is 17Q square by P square by Q square is a rational part and RHS is a irrational part. And both are equal we are saying here because this is of our wrong assumption that 2 root 3 minus root 5 is a rational number. So what you have to conclude? It is an irrational number. It is an irrational number. Is it clear? Next, third model. Third model is you have to prove that root 3 or root 5 or root 7 such etc. are irrational numbers. Is an irrational number. Show that or prove that it is an irrational number. Root 3 is an irrational number. Before going to the proof of this, I'll explain one statement that if P is a prime, P is a prime and P divides A square, P divides A square, where A belongs to positive integer, A belongs to Z plus, A belongs to Z plus, then what will happen? P also divides A also, P divides A also. P divides A also. P is a prime, P divides A square, then P divides A. So for example, we will take 2 is a prime. 2 belongs to prime numbers. And what? 2 divides 64. 2 divides 64, which can be written as 8 square. And then 2 divides what? 8 also. Root 64, that is nothing but 8 is root 64 is nothing but 8. 2 divides 8 also. That means if P is a prime, P divides A square, P divides A also. 2 is a prime, then 2 divides 64, then 2 divides 8. Okay, this statement you have to remember to prove this type of sums, this type of model problems. And one more concept here, what you are discussing, it is an irrational number. So let us assume that root 3 is, assumption is root 3 is rational. Root 3 is rational. So what is rational numbers? Can be written in the form of P by Q. And what are the conditions for rational number? Q is not equal to 0, P comma Q belongs to integers, and P and Q are co-primes. So previous sums we derived that contradiction we got for the rational and irrational numbers both are equal. There we assumed that, there we concluded that our statement is wrong and whatever is given is correct. Okay, so here I am telling that co-primes, I am underlining the co-primes because you have to know the co-prime definition. Co-primes are the numbers which have only common factor as 1, which do not have any other common factor other than 1. Okay, that you have to remember. So that means why I am saying that I will bring the definition, false statement for the definition of co-primes in this proof. Okay, so root 3 is equal to P by Q. Then what I am doing? Squaring on both sides. So 3 is equal to P square by Q square. 2 is equal to 3 is equal to P square by Q square. Then bring Q square to that side. 3Q square is equal to P square. 3Q square is equal to P square. Then just now I said the statement that if P is a prime, P divides A square, P divides A also. Here 3Q square is a multiple of 3. And if it is a multiple of D, that means P square is represented as 3Q square. P square is divisible by 3. Or 3 divides P square. If 3 divides P square, automatically what? 3 divides P also. Let us assume that this is the first statement, this is the second statement. Then P divides 3Q square is equal to P square you got. 3 divides P square, then 3 divides P also. Then P can be written as 3R, some multiple of some integer. P can be written as multiple of some integer, 3R. So if P is 3R, substitute in the equation 1, then 3Q square is equal to 3R whole square it becomes. That is 9R square. 9R square it becomes. 9R square, 3 gets cancelled 3 times. And Q square is equal to 3R square we got. The same way we got here again, see. Q square is equal to 3R square. That means 3R square is a multiple of 3. That is equal to Q square implies 3 divides Q square. 3 divides Q square. If 3 divides Q square, what will happen? 3 divides Q also. Take this as a statement 3. And what is the statement 2? P, 3 divides P. And what is the statement 3? 3 divides Q. The 3, that means 3 is the common divisor of P and Q. Divisor of P and Q. Common divisor of P and Q. What is the definition here wrong? Already we assumed that P and Q are co-primes. If they are co-primes, only one is the common factor or common divisor. But here we got 3 as the common divisor. So which contradicts the definition of coprimes? Which contradicts the definition of coprimes? So hence our assumption is wrong, and whatever is given, root 3 is an irrational number. Root 3 is an irrational number. Okay, have a nice day.